Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. You have been watching videos on quadratic polynomials, especially important for class 10 students, and I'm sure the videos are benefiting you and you are understanding the concepts involved in those videos. In this video, I'm going to take up some very important problems which have been asked in previous year papers, that is board exams, and these relate to the quadratic polynomials, that is the relationship between the zeros and the coefficients of a quadratic polynomial. So watch the entire video, class 10 students. This is going to be really important for you because these are previous year questions and they hardly exist in the NCERT book. So friends, all these things require smart things, so smart skills rather, and if you are competent enough, then these things are not going to trouble you because you just need the conceptual knowledge, and once you know the concepts, then the things become so easy. And just to develop smartness in you, we have brought out this exclusive nominal costing super combo of quant and reasoning. Quant and reasoning is something everybody is targeting, and everybody knows that without quant and reasoning we can't even dream of qualifying any competitive exams. Competition is huge, and that is why you need to do some different things or smart things to come up and come in the top 1% of the students. So this is a combo which includes the ebook of short tricks covering 24 different topics. Everything what you can think in quant is covered here, and this is the reasoning course where we have covered 18 different topics. Both of them come with video support directories. So if you don't understand something from the ebook, click and watch the link, the video, and this helps in developing 10 times faster speed of calculations. This has concepts, illustrations, previous year questions, everything. So friends, this is the best time to grab a copy of this nominal costing quant and reasoning combo. This is my WhatsApp number 9896369963. It is given in the description also here, and you can send me a message and I'll tell you how you can procure a copy of this super combo. Let's see the questions in hand now, friends. The first question, this has been, all the students who are prepared for this chapter, they should know this question. If the square of the difference of the zeros, square of the difference of the zeros. Now, if you assume that the zeros are alpha and beta, what do you mean by square of the difference of zeros? Difference of zeros is this and the square is this. Now this is given in the question as 144, and we need to find the value of p because there is a p involved here, so we need to find the value of p. Now we should know how to convert this alpha minus beta whole square in terms of alpha plus beta and alpha beta. Why? Because from this polynomial x square plus px plus 45, we can apply the relationship between zeros. Alpha plus beta is minus b over a, that is minus p, and alpha beta is c over a, that is 45 by 145. So you know the values of alpha plus beta and alpha beta, and that is why I need to convert this in terms of these two. So I should know that alpha minus beta whole square is actually alpha plus beta whole square minus 4 alpha beta. Now if I know this identity, job done. Why? Because I have to just put the values now. Alpha plus beta is minus p, so minus p square minus 4 alpha beta is 45, so 45 comes here, and this gives me 144. Pretty easy. After this, p square minus 180 equals 144, which gives me p square as 144 plus 180, which is 324. P square is 324, and 324 I know is 18 square, and so the value of p is plus minus 18, and there we go, the answer for the question. Now where is the typical thing in this question? One is you should know what is square of the difference of the zeros. What does he mean by that? And then you should know how to convert alpha minus beta whole square to something containing alpha plus beta and alpha beta, right? And then the relationship, obviously you should know the basic thing. What is the relationship between the coefficients and the zeros of a quadratic polynomial? Let's see another one. Find the value of k such that this polynomial, now the polynomial is given here, I'll assume that it is px, so x square minus k plus 6 times x plus twice of 2k minus 1. This is the polynomial, okay? Now what is given in this is the sum of zeros. So if you assume that the zeros are alpha and beta, then it is given that the sum of zeros is equal to half of their product. So half of the product of zeros. Sum of zeros alpha plus beta, right, is half of the product of zeros alpha beta. Now I should know what is alpha plus beta and alpha beta. Again the relationship works here. Alpha plus beta is minus b over a, alpha beta is c over a, minus b negative k plus 6. So k plus 6, because negative and negative becomes positive, upon a is 1, so I don't need to write 1. C over a, c is this entire thing, so this is 4k minus 2. So 4k minus 2 upon 1. So I can get rid of this one, I don't need this one. Now I'll put the values here and my job is done. So alpha plus beta is k plus 6, right? So k plus 6 is half of alpha beta is 4k minus 2. And so the 2 cross multiplies, you get 2k plus 12 equals 4k minus 2. And easy linear equation there to solve. 12 plus 2 equals 4k minus 2k. And so 2k equals 14, k equals 7. That is the answer for this question. Again, you should know the logic, you should know the relationship between zeros and the coefficients. You should know what does the question is asking us to do and what is the basic concept involved in there. Okay, let's see the next one. Here we have, if 1 0 of this, so this is the quadratic polynomial. So I'll assume that as px. That is a square plus 9 x square plus 13x plus 6a. That is the quadratic polynomial. Again, so zeros, I'll assume the zeros as alpha and beta, and so alpha plus beta is minus b over a, that is minus b is 13 over a is this entire thing, a square plus 9, and then alpha beta is c over a, c is 6a over a is this entire thing, a square plus 9. So I have some huge expressions here in alpha and beta. Now he says 1 0 is reciprocal of the other. Now what will happen if 1 0 is the reciprocal of the other? Just like one of the zeros is 3 by 2, then the other is 2 by 3, right? Reciprocals. So what will be their product? The product of reciprocals is always 1, and that is the concept you need here. So if you assume that beta is actually 1 by alpha, 1 0 is the reciprocal of the other, that means the product of zeros alpha beta will be alpha times 1 over alpha, that is 1. This is what I told you, that alpha beta will become 1. And what is alpha beta? Alpha beta is this. We already found out alpha beta, right? So 6a upon a square plus 9 becomes 1, and that gives me a square plus 9 equals 6a, which reduces to a quadratic equation if you bring 6a to the left hand side, and you can solve this pretty easily, right? The middle term splitting works here. Okay, so I think this is what, a minus 3 times a minus 3. Yeah, this works because this is a minus 3 whole square, and that means the value of a is 3. When you put it separately equal to 0, you will get a equal to 3. So again, 1 0 is the reciprocal of other, that means the product of zeros is 1. Let's see another one. So I'll solve half of this question and I'll leave this question as a DIY, do it yourself. Okay, so I'll do the first part. if minus 5 is one of the zeros of this, so px is 2x square plus px plus minus 15. Okay, so he says x equal to minus 5 is a 0, right? So that means if you put x equal to minus 5, this becomes 0. So 0 equals 2 times minus 5 square plus p times minus 5 minus 15, and so 0 equals, this is 25 2s are 50 minus 5p minus 15. So 5p equals 50 minus 15 35, so p is 7. Now I got the value of p. Now comes to the second part. There is another quadratic polynomial and he says this has both the zeros equal to each other. Now you should know when are the two zeros equal to each other. Repeated roots. It gets converted to a whole square. I am giving you some hints, okay? So now you have to try the second part. P is 7, just put it here. This is the expression, so p times x square plus x plus k, right? Put the value of p here and you will have another quadratic polynomial and try to convert that as a whole square, and then if you manipulate this question, you are going to get the value of k. Try this. Do post your comments here whether you could solve this or not, and watch the entire video 2 or 3 times. Okay, this is very important, very important. So friends, if you like this video, do share it with all your friends. Do subscribe to the channel and click the bell shaped icon for getting all the notifications of all the uploads on the channel. Do that's important. Practice. Do practice the concept. Thanks for watching this and all the best.